Hello, you're joining me as I'm working on a shoe rack for someone that is actually a viewer of the channel. Got in touch with me and asked if I could make a little shoe rack for them. So a bit of English oak, I happen to have a little bit in store, and I'm just putting a little cove detail. Hopefully you can see that. There's a little corner cut off around 50mm radius, and there's a little half round cove detail that I'm just machining around the outside of the panel. So it's just these three edges here. Started machining it on the Spindle Moulder using a profile cutter and limiter. I saw a little bit of breakout on the edges, so my initial thought was, I'll do a climb cut. I thought, I've not featured that in a video before, so this is a little video to show you what a climb cut is and a good example of when you would use it. So the machining action that I was using, like you would do on a Spindle Moulder, the cutter is, as you look at it here, on the left, and the block will spin in this direction. So that means traditionally you feed the timber in against the action of the cutter block, and that's the safest way to machine something. So as you machine the timber, it clears the material behind the cutter, and if anything happens and it slightly kicks, that's the worst reaction you get. It doesn't then further accelerate the piece of timber. That's like a proper cut and how you're meant to use the machine. But in certain situations you can do a climb cut. It's quite common with routers, and when you're using a router to get that nice clean finish around with a router bit, you can do a climb cut where you actually machine backwards, and you'll feel the action of the router actually start trying to propel the router along the piece of wood as you're making that cut, because as the cutter you're actually introducing the material from this side as it's spinning the same direction. You're introducing the material to the cutter, and as it's cutting it's actually trying to pull the material along with the cutter. So that's called a climb cut, and the reason you get a better finish is because as it's cutting into the timber, it's actually cutting into the wood that's already there, so it's a supported cut. Whereas when you cut like a normal cut, you're cutting the last bit of timber at the point at which it exits the wood. There's nothing there, so the cutter is effectively trying to cut timber that is unsupported by anything, and that's when you get that little bit of breakout at the edge of your cut. So I'll try and explain that a little bit better. I don't know if I've got a cutter that's suitable. So if I put this on here, so a traditional cut would be exiting the timber, and it'd be this point here or this edge that would be getting damaged. So the cut would effectively be pulling up like this, and the grain right on that edge is unsupported and is obviously trying to lift because the cutter is cutting in this action. With a climb cut, the point at which this edge is cut is actually on the entry to the timber, so the cutter in effect will be cutting into the wood, so it's supported by the rest of the material. The cut is dead clean on the point of entry to the timber. So that's the difference between the two. A climb cut is dangerous because you've obviously, as you're cutting, and on the Spindle Moulder as an example here, as you're cutting, all of this wood is uncut, so if this starts to snag or speed up, you introduce more timber to the cutter, and in turn it can then accelerate more because it's got more material to bite onto, and that's when you get something that will fly through the machine, you know, stick in the end of the workshop wall, which is not good. So generally a climb cut wants to be very, very well supported, either manually, which I probably wouldn't recommend, or I generally try to use, if you're using a climb cut, it's recommended that you use a mechanical form of feeding the timber through the machine. It's okay on a router with small router cutters, but on a Spindle Moulder, ideally you want a power feed, and set your power feed up to feed the material through. So obviously when we're setting the power feed up, we're looking to set it up slightly different to what we would normally. Normally you'd set the power feed up, this is an exaggerated example, so that the front wheel here is further away from the fence than the back wheel, so that as the material is fed through by the power feeder, it's also putting a little bit of a pressure exerted against the fence as well. So it's effectively trying to push that material in this direction across the fence, and because the fence is there, it runs nice and tightly in a straight line along the fence. So when we're running it backwards, obviously we've got to adjust that so that the back wheel has the most gap and the wheel here, which effectively will be the back wheel, is closer to the fence. And I need to run the wheels in reverse, obviously, and you want to keep the spindle moulder in the same direction that you would normally run it in. So we've got a anti-clockwise direction of rotation on the spindle, and we're running the power feeder in reverse. I know a lot of guys actually use this quite a lot of the time, even in windows for like big rebates and stuff. If you've got the machinery to do it, it is possible. It's just, it can create a bit more of a problem with chip bruising on cutters and vibrations and stuff. It's probably best, if you are wanting to do a climb cut finish, to machine a component to very near finished dimensions and then do your climb cut to actually do the finished cut. So I've nearly finished machining these here, but I've got one panel left that I need to machine before I realise that I can make a video of this. So we're going to be machining this edge along here, and I'll stop it halfway through so that you can see what's going on. There we can see, because we're doing that climb cut and the bit of material that's being cut to the edge of the wood is being cut first and cut into, every part of that cut is absolutely pristine. It's as sharp as anything, so you're not going to get any breakout from a climb cut because you're cutting into the wood fibres. If we then machine this through in the traditional manner, from this side of the machine, cutting out of the timber, all of this edge here, sort of this corner of the timber, will be starting to splinter off and break out all the way down this edge, but because of that climb cut, it's lovely and sharp. So what I can actually do is show you the difference between the two. So if I set this up, it's the same speeds on everything. Just adjust the power feed slightly. I can feed another piece through in the other direction and show you the difference between the two. So there's a little bit of a comparison between the two. You can see on this cut that wasn't a climb cut, all the grain from sort of this point here to this edge is starting to tear, and the edge there is pretty much undefined and not very sharp at all. So if I was to stop that moulding to make a feature out of a stop chamfer there, that would be a pretty poor cut and wouldn't look very nice at all. So that's when you need to use a climb cut to get that absolutely perfect finish. So there we go, that is a climb cut. If you've not got a spindle moulder, you can use the same technique with a router. So next time you're running a moulding around a panel, instead of going the traditional way, going sort of against the cutter and blasting all the edge of your moulding and creating little chips along it, try running it very, very carefully, holding onto it well, but try running it backwards along the piece of timber, and that's called a climb cut. You should be able to see the difference between the two.